Have you ever looked up at the night sky and wondered about the origins of the moon? While it is commonly accepted that the moon formed from debris after a massive collision between Earth and a Mars-sized body, some scientists have proposed an even more fascinating theory: that the moon may have once been part of Venus. This idea, though controversial, has gained traction in recent years as researchers continue to explore the mysteries of our solar system. The theory begins with the early solar system, a chaotic and violent place where planets frequently collided. Venus, often called Earth's twin due to its similar size and composition, might have had a natural satellite of its own. A colossal impact could have ejected this satellite from Venus's gravitational pull, sending it on a trajectory that eventually led it to the orbit of Earth. This hypothesis challenges the traditional giant impact theory and opens up new avenues for understanding planetary formation. One of the most intriguing pieces of evidence supporting this theory comes from the comparison of isotopic compositions. Studies have shown that the isotopic ratios of oxygen on the moon are remarkably similar to those on Earth. However, recent research has indicated that Venus's atmosphere also shares these isotopic characteristics. This similarity suggests a common origin, or, at the very least, a significant exchange of material between these celestial bodies. Additionally, the peculiarities of the moon's orbit lend some credence to the idea that it might not have formed solely from Earth. The moon's orbit is slightly inclined relative to Earth's equator, and its distance from Earth is gradually increasing. These anomalies could be explained if the moon was captured by Earth's gravity after being ejected from Venus. While this capture scenario is less likely than the giant impact theory, it is not entirely impossible. Another fascinating aspect to consider is the geological history of Venus. Venus has an incredibly hostile surface environment, with temperatures hot enough to melt lead and atmospheric pressure 92 times that of Earth. Yet, there are indications that Venus may have once had liquid water and a more temperate climate. If the moon originated from Venus, it could provide clues about the planet's past conditions and its dramatic transformation. Moreover, the study of lunar samples brought back by the Apollo missions has revealed some surprising findings. For instance, the presence of certain minerals that are rare on Earth but could potentially be more common on Venus raises questions about the moon's origins. These minerals, combined with the isotopic evidence, make the Venusian origin theory an exciting possibility worth exploring. As we continue to send missions to both the moon and Venus, future discoveries may provide more definitive answers. The upcoming Artemis missions, aiming to establish a sustainable human presence on the moon, and the planned missions to explore Venus's atmosphere and surface, will likely yield new data. This data could either support or refute the idea that the moon was once part of Venus. In conclusion, while the theory that the moon was once part of Venus remains speculative, it is a captivating idea that challenges our understanding of planetary formation and the dynamic history of our solar system. As technology advances and we gather more information, we may one day uncover the true origins of our closest celestial neighbor.